Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course. Computer Systems Security Part 2. In the previous chapter we discussed malicious software, which is one of the biggest threats to computer systems security. But it doesn't stop there. Your computer can be accessed in other ways, including via the UEFI BIOS and by external devices. A computer doesn't just mean that desktop computer at a user's desk. It also means laptops, tablets, smartphones, actually any other systems or devices that have processing power and an operating system. These threats can be eliminated by proper configuration of the UEFI BIOS and providing for security applications on every one of your client computers on the network, be they desktop computers, laptop, mobile devices or IoT devices. Implementing security applications. In the previous chapter we discussed endpoint protection platforms, namely anti-malware suites. These application suites usually have antivirus, anti-spyware and anti-spam components. Often they also have a built-in firewall known as a personal firewall, and perhaps the application suite also has a built-in intrusion detection system, IDS, a piece of software that monitors and analyzes the systems in an attempt to detect malicious activity. The type of IDS that a client computer would have is a host-based intrusion detection system, HIDS, but there are other types of standalone software firewalls and HIDS. We cover these in just a bit. Another type of built-in security is the pop-up blocker integrated into web browsers and web browser add-ons. Pop-up blockers help users avoid websites that could be malicious. Let's discuss these security applications in a little more depth, starting with personal firewalls. Personal software firewalls. Personal firewalls are applications that protect an individual computer from unwanted internet traffic. They do so by a set of rules and policies. Some personal firewalls, also known as host-based firewalls, prompt the user for permission to enable particular applications to access the internet. In addition, some personal firewalls have the capability to detect intrusions to a computer and block these intrusions. This is a basic form of a HIDS we talk more about in the next section. Examples of software-based firewalls include the following: Windows firewall. Built into Windows, a basic version is accessible by the control panel or by typing firewall.cpl in the run prompt or command prompt. The advanced version, Windows Firewall with advanced security, can be accessed by typing wf.msc in the run prompt or command prompt. This advanced version enables a user to perform more in-depth configurations such as rules. Zone Alarm, originally a free product, is still available. See the following link. This was purchased by Checkpoint and is now offered as part of a suite of security applications. PF Packet Filter, IPFW IP Firewall. PF is a command line based firewall built into OS X version 10.10 and higher Mac OS. Its predecessor IPFW was available in OS X through 10.9 but was deprecated in 10.7. Some OS X versions and Mac OS also include a graphical firewall titled Firewall. PF and IPFW are also used in FreeBSD. IP tables used in Linux systems is used to configure the tables provided by the Linux kernel. Firewall and its rules can be extended upon using various configurations, tools and third-party add-ons. Anti-malware application suites from Symantec, McAfee, Kaspersky and so on include personal firewalls as well. This has become a common trend, and you can expect to see personal firewall applications built into most anti-malware application suites in the future. Because they are software and because of the ever increasing level of internet attacks, personal firewalls should be updated often, and in many cases it is preferable to have them auto update, although this depends on your organization's policies. As software, a personal firewall can utilize some of the computer's resources. In the late 1990s and early 2000s, there were some complaints that particular anti-malware suites used too much CPU power and RAM, sometimes to the point of crashing the computer. In some cases, this was because of the resources used by the firewall. Today, some anti-malware suites run better than others depending on the scenario. So a smart systems administrator selects an endpoint protection platform that has a small footprint and one that works best with the organization's operating systems and applications. Some organizations opt not to use personal firewall and client computers and instead focus more on network-based firewalls and other security precautions. The choice whether to use personal firewalls, network-based firewalls, or both can vary, but careful analysis should be performed. A decision is made. For example, take an organization that accepts credit card payments over the phone and performs the transactions over the internet. The individual computers that are used to carry out the transactions need to have a personal firewall installed with the proper ports filtered in order to comply with financial regulations. Personal firewalls, like any software application, can also be the victim of attack if worms or other malware compromise the system. The firewall could be affected. This just reinforces the concept that antivirus suites should be updated often. Daily updates would be the optimal solution. A common scenario for security in small offices, home offices, is to have a 4-port SOHO router firewall protecting the network and updated personal firewalls on every client computer. This combination provides 2 levels of protection for the average user. This defense layering approach is normally adequate for smaller networks, but larger networks usually require concentrate more on network firewalls and network-based IDSs than on personal firewalls, although it is common to see both levels of firewall security in larger networks as well. Host-based intrusion detection systems. Let's start by talking about intrusion detection systems, IDS in general. An IDS is used to monitor an individual computer system or network or a portion of a network and analyze data that passes through to identify incidents, attacks, and so forth. You should be aware of 2 types of IDSs for the exam. Host-based intrusion detection system, HIDS, loaded on an individual computer. It analyzes and monitors what happens inside that computer. For example, whether any changes have been made to file integrity. A HIDS is installed directly within the operating system, so it's not considered to be an inline device, unlike other network-based IDS solutions. One of the advantages of using a HIDS is that it can interpret encrypted traffic. Disadvantages include its purchase price, its resource-intensive operation, and its default local storage of the HIDS object database. If something happens to the computer, the database will be unavailable. Network Intrusion Detection System, NIDS, can be loaded on the computer or can be a standalone appliance, but it checks all the packets that pass through the network interfaces, enabling it to see more than just one computer. Because of this, an NIDS is considered to be an inline device. Advantages include the fact that it is less expensive and less resource intensive, and an entire network can be scanned for malicious activity as opposed to just one computer. Of course, the disadvantage is that NIDS cannot monitor for things that happen within the operating system. Following are two main types of monitoring that an IDS can carry out. Statistical anomaly. It establishes a performance baseline based on normal network traffic evaluations and then compares current network traffic activity with the baseline to detect whether it is within baseline parameters. If the sampled traffic is outside baseline parameters, an alarm is triggered and sent to the administrator. Signature based. Network traffic is analysed for predetermined network patterns which are known as signatures. These signatures are stored in a database that must be updated regularly to have an effect. Many attacks today have their own distinct signatures. However, only the specific attack that matches the signature will be detected. Malicious activity with a slightly different signature might be missed. IDS solutions need to be accurate and updated often to avoid misidentification of legitimate traffic, or worse, the misidentification of attacks. Following are two main types of misidentification you need to know for the exam. False positive. An IDS identifies legitimate traffic as something malicious. False negative. An IDS identifies an attack as legitimate activity. For example, if the IDS does not have a particular attack signature in its database, the IDS will most likely not detect the attack, believing it to be legitimate, and the attack will run its course without any IDS warnings. Some antivirus application suites have basic HIDS functionality, but true HIDS solutions are individual and separate applications that monitor log files, check for file integrity, monitor policies, detect rootkits, and alert the administrator in real time of any changes to the host. This is all done in an effort to detect malicious activity such as spamming, zombie, botnet activity, identity theft, keystroke logging, and so on. 3 examples of HIDS applications include the following: Trend Micro OSSEC, a free solution with versions of several platforms, versus a commercial HIDS file integrity monitoring solution for Windows. Tripwire, another commercial HIDS solution. There are several compliance regulations that require the type of file integrity monitoring that a HIDS can provide, include PCI DSS NIST 853. When selecting a HIDS, make sure it meets the criteria of any compliance regulations that your organization must adhere to. It is important to protect the HIDS database because this can be a target of attackers. For attackers, it should either be encrypted, stored on some sort of read-only memory, or stored outside the system. If an IDS observes an incident, it notifies the system or network administrator so that she might quarantine and fix the problem. However, over time, the need for prevention has become more desirable, so intrusion prevention systems, IPSs, and intrusion detection and prevention systems, IDPSs, were developed. For the local computer systems, this is known as host-based IPS or HIPS. These not only detect incidents and attacks, but also attempt to prevent them from doing any real damage to the computer or to the network. Once again, typical companies such as McAfee and Symantec and the aforementioned HIDS, HIPS providers offer host-based intrusion prevention systems. There are also downloadable implementations for Linux that prevent malicious code from executing, such as security enhanced Linux SE Linux. It's a set of kernel modifications originally developed by the National Security Agency NSA, but was released to the open source community for download. A security administrator can review the logs of a host-based IDS at any time. However, if the computer has been shut down, the administrator will not be able to review the information pertaining to system processes and network processes, nor information stored in memory, because all these items are volatile. HIDS logs that refer to archive storage, the MBR or GPT, the system disk, email, and so on, will still be available for review. By reviewing the logs of HIDS, a security administrator can find out if the computer has been compromised by malware or if it is communicating with a botnet. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.